Hi, welcome to the Computer Science Professional Development video series. This is series number 2 on the essential concepts in the computer science standard. The second video is on the data and analysis overarching concept. My name is Dan Schneider. I'm a high school computer science teacher here in Arizona, and I'm a member of the Arizona chapter of the Computer Science Teachers Association. So first, an overview. The Arizona Computer Science Standards are organized into 5 overarching concepts that span all grade levels. Today, we'll be focusing only on the data and analysis concept. Studying each concept individually can help us see a progression of knowledge from early elementary through middle school and high school. When reading the standards themselves, they are organized first by grade level, then by concept, then subconcept, and lastly, an identifying number. In today's video, we only be looking at the data and analysis standards, which have a DA in the second position. Our goals today are to understand data and analysis at a broad level and see how its 4 subconcepts, collection, storage, visualization and transformation, and inference and models, help guide a progression of knowledge from elementary school through high school. We'll look at example standards in each of the grade bands with a focus on how this concept progresses through these bands. We will also look at ways that teachers may already be emphasizing these concepts in their classrooms and examine resources and lesson ideas that teachers can use to teach these concepts. So first, big picture. What is data and analysis? One way that we can best understand this concept is by looking at a progression of each of the subconcepts, starting with collection. Students consider how data can be collected in a variety of formats, including how technology can aid in this process. This may include using an electronic device and sensor to collect environmental data, such as temperature, light levels, etc. Other devices may be hooked up to these sensors to react accordingly, such as turning on an LED when the light level gets low, or the data may be stored for later analysis. This can also include survey data either on paper or pencil using an electronic template such as Google Forms. These surveys can be qualitative and used for larger data analysis projects later. Another completely reasonable way to generate data is through natural probability methods, such as rolling a dice or flipping a coin and keeping track of the results to be analyzed in a math or science class. In fact, in early and mid-grade levels, many of the collection standards can overlap with probability lessons and science experiments. Once all that data is collected, now we look at how it is stored. For example, students explicitly consider how a file type and metadata can affect how information is stored, such as saving an image in a smaller resolution versus a larger resolution. Students also learn how data such as images or text are eventually broken down into smaller representation, such as pixels or ASCII, and ultimately end up as ones and zeros called binary. There are a variety of fun resources available for teachers that can introduce binary in the context of creating pixel images or through mathematical magic tricks, making it easier to connect binary to the larger context of representing text and images. Students also become fluent with a variety of programs that can represent and manipulate data, such as spreadsheet programs or database programs. They are introduced to functions that can help them organize this data for later analysis, such as sorting or filtering data. At later levels, students also consider the physical trade-offs with how data is stored, considering the pros and cons of cloud storage versus physical storage versus on their mobile device. Once they have their data collected and stored, students can perform operations on their data that transform it into other representations. For example, students may consider how they can take a color image and use that pixel data to turn it into a grayscale image. Importantly, students begin to understand how this might work when looking at the actual pixel data rather than only using a familiar image editing program. Students also use programs to analyze and represent their data in easier to understand charts and graphs. We consider what types of graphs are best used to represent certain types of data. For example, when is a bar chart more appropriate than a line graph? This aspect of the data and analysis concept overlaps heavily with math and science standards on data analysis. However, there are additional opportunities within the computer science standards for students to present or describe their choice of representation, allowing students to emphasize communication and presentation skills when explaining their choice of data representation. Lastly, once the data has been represented appropriately, students can make inferences and construct models based on this data. We'll look at 2 examples of where this happens for 2 types of data. Quantitative data, which is based on numbers and values, such as those collected by sensors, and qualitative data, which is based on choice responses, such as those collected from surveys given to other students. For example, one type of qualitative model that students may be familiar with already is how election results are gathered and predicted. Surveys are given to a cross-section of individuals, and based on those responses, patterns are analyzed and predictions are made based on how certain responses correlate together. Qualitative data and other predictions also allow students to consider issues of bias that may be inherent in data and discuss ways that surveys can be implemented with fidelity and accuracy to avoid this bias. On the other side, one type of quantitative model that students may already be familiar with is how the weather is modeled and predicted. Meteorologists use a variety of sensors to collect numerical data, analyze those patterns, and create a prediction model for the weather. Similarly, once students have their data collected and visualized, they can begin to make predictions based on their sense of data and possibly construct their own model to predict future results. A summary of the data analysis concept is provided in the state standards as well as here. This concept is broken down into 4 additional subconcepts. The first 2, collection and storage, are provided on this slide. The next 2 are described on the next slide. I won't take time to read these out loud, but I invite you to pause this video and read through this summary to begin to understand and see how these subconcepts are first introduced and then progress through the grade levels. I will also pause on the next slide if you want to read through those descriptions as well. And here are the descriptions for visualization and transformation and inference and models. Again, feel free to pause the video and read through these summaries in order to begin seeing how these subconcepts are first introduced and progress. Awesome. So let's start by looking at some standards in the beginning grade levels. I've selected 2 standards from grade 1 and 2 to start with. Generally speaking, students are introduced to methods of collecting data from a variety of sources, such as journaling, surveys, or recording data from experiments. Many of these activities can be incorporated into other subjects, such as asking students to interview or survey their family or community as part of a larger school project, or recording data as part of a math or science lesson. If you are already teaching lessons involving data collection, perhaps consider the variety of ways this data can be recorded and make this more explicit to students, or offer them choice in how they may want to collect and record their data. Another set of standards at this level involve manipulating data and files on a computer. These standards usually overlap with work already happening to acclimate and teach digital literacy skills to students, opening files, copying files, searching for files, etc. At this level, students should begin to become more aware that files on their computer are a type of data, and they should become more comfortable creating and retrieving computer data. Another key point is that many of the standards at this level include the phrase "with teacher guidance," acknowledging that students still need assistance navigating technology and determining which programs are useful for which activities. Guiding students through technology is a key aspect of standards at this level, making them more aware of the times they are using data to perform operations. Many of these standards can be incorporated into work you already do, but another useful resource is the K5 is not just coding repository of lessons and resources. If there are particular standards that seem too disconnected from the work already happening in the classroom, this website is a great resource for how you can incorporate those standards more intentionally in your classroom. In upper elementary, students continue to develop their digital computer skills and begin to shine an analytical light on the data they collect and how they collect it. We begin to notice that certain file types have different file extensions and that certain programs will only open certain file types. They can begin to categorize files based on these types, which is a useful skill of computer literacy in general, noticing what types of files are a document versus an image versus a video. As they progress in upper elementary, they begin to notice patterns in file sizes. For example, some images can be stored with a smaller file size, but have worse quality. This concept is further emphasized at greater detail in middle and high school. Students also begin to analyze data and notice when they can draw conclusions from patterns in the data. In math or science class, this can be used to reinforce known relationships, such as the probability of flipping a coin. These activities also overlap with this level of computer science, but the emphasis here is on the conclusions and predictions that are made from data even if those conclusions turn out to be incorrect. The act of noticing patterns in data and arguing for a certain prediction or interpretation is the skill that is most reinforced and progresses into later standards. Finally, students also consider the choice of tool that they want to use to collect data. For example, they may notice that a paper survey may lead to more student participation, but is harder to gather and analyze the data afterwards. Whereas a digital survey, such as on Google Forms, can be analyzed quicker, but may be less accessible to some students. From a qualitative perspective, students also begin to consider what types of sensors can be used to collect data from an environment, which complements some of the computing system standards that also occur at upper elementary, where students become more familiar with computing devices and what they can do. A great resource at this level has been put together by Gilbert Public Schools and includes activities for each standard broken down by grade level, as well as advice for how to tweak activities you are probably already doing so they now meet these standards. In middle school, students continue to turn a critical eye on the data they collect and get more concrete with how data is truly represented on a computer. In sixth grade, we see students beginning to analyze and criticize models and predictions based on the data it is given. This offers a foundation for conversations about machine learning and bias that occur at later grade levels. Perhaps surprisingly, these standards best overlap with history lessons, where students can see historical examples of how bad data has influenced decisions and models from the past, or examples where entire groups of people were left out of a data-driven decision, leading to unfortunate impacts in their communities. For example, a discussion can be had about how car airbags unintentionally wounded female drivers when they were first released because all of the testing data was based on male engineers. In seventh grade, we see students explicitly collecting data and using programs and tools to present their data and support a claim. The emphasis on tools usually aligns with other digital citizenship efforts, especially in training students on how to use a spreadsheet or presentation program that supports them in all of their courses. In eighth grades, we see students that are learning the behind-the-scenes representations that are used for data, specifically binary and ASCII, which is the encoding that we use to represent letters and numbers on a computer. The emphasis at this level is understanding how multiple representations can make certain operations easier for a computer, but harder for a human. This is especially true for image and text manipulation, which can sometimes be easier for a computer at the binary level rather than at the higher image level. Teaching binary and these lower level representations may seem a little daunting, but luckily there are a variety of resources available via the CS Unplugged website. These lessons and resources can be used to integrate these activities into other subjects and can be done in classrooms without a computer. If binary representations are something new and slightly intimidating, or you're looking for a way to teach these standards outside of a standalone computer science course, these CS Unplugged resources are a great help. One nice thing about this concept at the high school level is there are only 4 standards. So all of them for all of high school are on this single slide right here. We see a progression from earlier grades where students are continuing to make interactive visualizations. We see an emphasis on multiple representations of data with explicit attention to conversions. We see a new focus on looking at the trade-offs involved in storing data, which intersects nicely with some of the impacts of computing standards that focus on privacy. And lastly, we continue to develop models based on the data we collect. As we can see, these are all of the data and analysis standards at the high school level, and there are a few projects that are worthwhile to show mastery of these standards. Students can participate in a project that goes through all of the sub-concepts: collecting, storing, visualizing, and modeling to tell a story with data, trying to make some sort of broader conclusion based on the data they've collected. Students can also emphasize the quantitative aspect of data collection, creating something such as a sensor network, a series of devices that are all hooked up together and collecting data, and then students can analyze this data for a broader point. An example that was done in Chicago is the Array of Things project, which is both a citywide project and a collaboration with a group of high school students. So we have reached the end of the video. Thanks for following along with us. As a reminder, here were our goals for today: to be able to have a broader foundation of the data and analysis concept and how it progresses throughout the entire K-12 experience. In addition to the individual resources listed earlier, there are several general resources that may be useful in diving deeper into teaching these computer science standards. We're grateful for the work of other organizations here in Arizona and around the nation for curating and sharing these teacher-vetted resources and strategies. We have the Arizona Department of Education collection of resources, which includes the Gilbert Public Schools resources mentioned earlier. We have the Computer Science Teachers Association of Arizona website, which is a collection of news and professional development events that are relevant for anyone interested in teaching computer science. We have the Computer Science in San Francisco initiative, which is a collection of teachers and districts in San Francisco who have developed curriculum and resources for teaching computer science at all grade levels. We have New York City's CS for All blueprint, which includes videos of pedagogical strategies that can be used in computer science classrooms, as well as curriculum for all grade levels. And lastly, as was mentioned before, the CS Unplugged website, which is a variety of resources at all grade levels, especially useful as standalone lessons or lessons without a computer. So with that, thanks for watching. Happy teaching.